Okay, our topic is decarboxylation. Decarboxylation. അതിനകത്ത് ഫസ്റ്റ് പഠിക്കാനുള്ളത് ആക്ഷൻ ഓഫ് സോഡ ലൈം ഓൺ സോഡിയം കാർബോക്സിലേറ്റ് ഗ്രൂപ്പാണ്. അതിൽ എങ്ങനെയാണ് റിയാക്ഷൻ എന്ന് പറഞ്ഞാൽ ഡീകാർബോക്സിലേഷൻ the reaction of sodium salt of an aliphatic monocarboxylic acid with soda lime. Soda lime is the 3:1 mixture of sodium hydroxide and calcium oxide. The product formed will be an alkane with one carbon less than the parent salt, means sodium salt. Okay, the example for example we can write that generally RCOONA, sodium salt of a monocarboxylic acid group, reacting with or heated with 3:1 mixture of sodium hydroxide and calcium oxide yields an alkane, that is RH, and sodium carbonate. Okay, sodium carbonate. Here the alkane formed will be having one carbon less than that of the parent carboxylate group. Okay, example, when sodium acetate is treated with soda lime, it forms methane. Okay, and when sodium propionate CH3CH2COONA is treated with soda lime or heated with the soda lime forms ethane. Okay, next, in the case of aromatic monocarboxylic acid, that is, for example, sodium benzoate, when reacted or heated with the soda lime forms benzene and sodium carbonate. Okay, some of the aromatic monocarboxylic acids themselves undergo decarboxylation on heating with the soda lime, that is, when benzoic acid is itself, that is not a sodium salt, or it's a carboxylic acid only, when treated with the soda lime or heated with the soda lime forms benzene. Okay, that is the conditions for this reaction is a high temperature. High temperature is ensured for complete decarboxylation and to make the deliquescent sodium hydroxide dry, or to keep the sodium hydroxide dry. Okay, there in this reaction we can see decarboxylation process, that is, one carbon dioxide molecule from the sodium salt is removed by the sodium hydroxide and calcium oxide group to sodium carbonate. Okay, sodium carbonate. Then the mechanism, when we are taking care about this mechanism of the reaction, first step is the formation of carbanion. That is R minus. Formation of carbanion, that is, here these two electrons are transferred, that is, here we are considering the RCOO minus group, RCOO minus group. Here this O minus, here these two electrons will transfer to this form, this bond, and here, and this electrons from the bond is transferred to R. Then it forms carbanion plus carbon dioxide. Okay, carbanion plus carbon dioxide. Next step is the carbanion reacts with the proton source to form CH bond, R plus H plus giving RH. Next step is the decarboxylation of free acid. Here RCOOH group. And what is decarboxylation of free acid? Here those bonded electrons are transferred to O. Then next step, RCOO minus formed. Here O minus here this electrons from the O minus group, that is RCOO minus group, group is transferred to this bond, and R minus will be, that is an carbanion is formed, and this carbanion reacts with the H plus, forms RH. Okay, RH and carbon dioxide. Okay, next is the coarse electrolysis. Here also we can observe a decarboxylation process. In coarse electrolysis, a concentrated aqueous solution of sodium or potassium salt of carboxylic acid. A concentrated aqueous solution of sodium or potassium salt of carboxylic acid undergo electrolysis to form an alkane. Alkane normally having an even number of alkane group. Okay, then even number of carbon atoms. Okay, even number of carbon atom containing alkane. Okay, then carbon dioxide, sodium hydroxide and H2. Example, when sodium acetate solution or aqueous solution of sodium acetate undergo electrolysis, forms ethane and carbon dioxide, sodium hydroxide and H2. Okay, ethane. This here the two molecules formation is such that this bond breaks and carbon dioxide, two molecules of carbon dioxide and Na plus will go with OH minus, and H2A will be evolved here in this reaction, and the main product is ethane. Okay, then mechanism for this reaction is given by first step, ionization. Two molecules of CH3COO Na, that means CH3COON, sodium salt of acetic acid, undergo ionization to give 2 CH3COO minus and 2 Na plus, and at the anode reaction, 2 CH3COO minus loses 2 electron at the anode and forms acetate radical first, and which will undergo rearrangement and forms methyl radical and carbon dioxide, and the methyl radicals reacts to form ethane. Ethane is evolved at anode, and at the cathode, H2O accepting 1 electron forms OH minus and H plus, and the 2 H plus forms H2 at the anode. H2 gas is evolved at cathode. H2 gas is evolved at cathode. Okay.